Welcome back to this channel. And in today's part, we are actually going to discuss pointers, which is a very, very delicate and important topic for C language. And today, the chapter which we are discussing is actually chapter number 7. The topics in this chapter you can see right in front of you. This is the today's agenda, as you can see over there. Like they are like something 11 or 12 topics over there. Since this is a very delicate topic, so I'm going to bifurcate this thing not in just two lectures. I'm going to bifurcate it into three parts over there. So I want your complete attention over there, and that's why I will make it into small parts. So trying to basically make you more understand, and I will try to make more use of examples which I will be writing down at runtime with you. First of all, starting with what is actually a pointer. Now, pointer word in English language, whenever we are using the word pointer, which means something which is going to use to point at. So if you are having like supposedly a teacher standing in classroom, he has some a laser pointer in his hand, then he is actually pointing out towards some area of that board or some whiteboard or the chalkboard over there. So it's actually pointing out. So in C language, the same thing is pointers over there. So it's going to point to something. So the word pointer is actually going to point towards something. And that something over here, now listen this very carefully, that something over here is actually going to be a memory address. Now, what is memory? Now, before I proceed on, because maybe you are not that good in programming or you are not very good accustomed to the working of a PC at present, your computer is based upon two memories inside it. One is called as the main memory, another one is called as the secondary memory. The computer stores some data permanently, that is actually called as the secondary memory, or at the hard disk, the universal serial bus, USB over there, or any something like that, or storage devices over there. So those are secondary devices. The one which I'm talking about is the main memory, and main memory is the RAM. So random access memory is actually the one which is going to be pointed out by the pointers. Now, why we need to point out some data inside pointers or inside RAM over there? Now, the answer is very simple for that. The answer is simple here that whenever you are working on a program, the program has some variables, which means data buckets, and those data buckets have to be saved inside the RAM, because when the program is running, they are not permanently stored over there. So if you are initializing two variables over there, let's say I have some program over there. Let me just write down some program here right in front of you. I'm just copying some text over here so that I can actually write down. I have a pointer on program over there. And here inside it, let's say I have some program over there. And inside this, I'm not going to write down from the my AI course over there. So I have something, let's say I have an int x equal to 7 or 8 something, and then I have int y is equal to 9 over there. What is this over here? Int x and 9, they are in x and y, they are two variables, they are integer data types, and they are having the values 8 and 9. Where is this 8 and 9 stored? This 8 and 9 is stored inside the RAM. And of course, in RAM, there is going to be an address. So RAM is just like a mailbox in which you have an address, and you are going to store that data inside that mailbox depending upon its address. So this X is going to have an address inside the RAM. This Y is also going to have an address in RAM, and it's going to store that 8 and 9 inside it. Now, why pointers over here? Let me just use another word now. Now, when I'm calling the word pointer, this means that pointer is going to be another variable, but it will be pointing out towards the memory address of X variable or the memory address of Y variable. Now here I have two variables, X and Y. So let's say I want to have another variable, and this time I'm going to use static X capital PTR. Now, why I'm using this capital PTR over there is totally up to me. Now, PTR is actually just an abbreviation for pointer, so that's why I'm used it over there. And the word X I've used because this is the pointer of X variable. So it's you can name it A, B, C, D, whatever. It's totally up to you. But here I have just used it as X variable. The only difference over here, because this is now a pointer, because there is an static over there. Now the same static we have been using up till now in a lot amount of patterns and all that stuff or videos over there. This thing over here is with a variable name without any spacing over there is actually telling the C compiler that this word over there, xptr with an asterisk in start, is actually telling it that this is a pointer. So this pointer still it's just going to be declared. It's still not initialized. It's not told that it's a pointer of which thing. So I can now have another variable. Let's say this is int static y pointer. And over here, I will just come to this. Actually, the AI is actually giving me this analysis automatically over there. This is actually the one thing. So this is integer. Why integer? Why? Because this particular term, that is static y ptr, it can be small p also. So don't worry on that. I will talk this one on the slides as well. There's a whole slide on that part. That normally whenever in C language, you are going to have a pointer declared. The normal word is using, you call it as capital PTR with a variable name over there, or you can use P underscore, or you can just use PT. So it's totally up to you. You just have to use a common nomenclature which is used by some of the programmers all around the world. So this YPTR or XPTR or static XPTR is actually a variable, and that variable is actually pointing out to a memory address which is storing an int data type. That's why it's called as an int. So whatever name you are choosing over there with the word static is must. Remember, static is must, because this is actually telling it that this is actually a pointer. If the static is not there, then it's just simple. If you just write down X over there is no static over there, then this means that this is just a simple variable with an integer data type, and the static actually tells it that this is. Now, when you have declared these two pointers over there, now which pointer points to which address is done by this thing, which I'm now going to show you here just now, which AI actually giving to me. Now, what is this XPTR? XPTR is equal to, without the static sign. Remember, I'm not using the static because I have declared it. Now I have declared it, static XPTR is declared. So just XPTR is already going to tell me, okay, this is that pointer. So XPTR is actually equal to and X. Now, if you remember over there, if you remember your previous thing, whenever you were having a scanf command, and inside that scanf command, you were always going to have this and X and Y. Why they were used? They were actually pointing out that you are going to take some input from the user and store them inside X and Y. And this and was actually telling you the address of that X and Y variable in the RAM. So same thing over there, that now you want to find out the address of this X and this Y. So you are using this and X and Y. So this is a pointer. These are two simple variables having a value 8 and 9. They are integers. And this one is a pointer. These two are pointers. This XPTR is pointing out to the address of X. Now, what is the advantage of this? That's actually the point. So what is the advantage of this? Now, if you don't want to use X and Y, since XPTR is directly giving you the value, whatever is stored over there. So let's say I want to now printf, let's say. Now, in printf, let's just say, I just want to, I'm not going to use this one. So value of X PTR. Okay, so it's already giving it over there. And let me just use this one. So I'm using the AI, whatever it's giving me. Now, what is written over there? Value of XPTR is, now this is percentage P. Now, this is something new for you. You have not used percentage P up till now. P here stands for the memory address. So this is percentage P. Then there is backslash N. And then the value of YPTR is percentage P. And here, instead of this percentage P, which is actually the format specifier, you're writing down XPTR and YPTR. Now, the important thing, question over here. When I'm going to run this program, what is going to be written in the two lines? That's the question over there. For that question, let me just save it and run this program. Now, when this runs on, now you can see what is happening over there. What is written over there? Value of xptr is 0x into 16EF49469AC. What is this? This is hexadecimal. We never stored that wing. But remember, memory is reached by hexadecimal addresses. Your memory is always, now just for commenting, your memory is always addressed as hexadecimal numbers. So the output code, it has already given me, will be in hexadecimal format. The value of xptr and yptr will be the memory addresses of x and y respectively. Now, what is the 0x? This 0x telling you there's a hexadecimal number, nothing fancy about it. And you can see very easily because int x is here, int y is there. There is slight difference in this. This one is AC and this one is A8 at the last. So of course, in between them, there is some other data being stored over there. The compiler knows it, how it's actually storing it. So I'm not saying that these two are in two consecutive lines. So this will be in one memory address. This will be in one memory address. Of course, this will be changed over there. So that's why it's having a different memory address over there. Now, after this thing, let's see, I want to write down another printf, and that printf now is going to, because what I've just done, I have written the memory address of x because this was and x and this was and y. So now I want to actually print the value of xpti over here. This one, value of x is percentage d again, and value of y is, and now this time I'm not putting x and y here. I am putting steric xptr and steric yptr. Now what I'm going to do, what is going to print? It's going to print the value of x and y, which is actually inside the memory address of this steric xptr. Previously, I just printed xptr. That was the memory address. That was the memory address in hex. That's why I had percentage %p over there. Now this time I have steric xptr. And what is the steric ptr? It's a pointer for that memory address which is stored inside xptr. I'm again repeating. Steric xptr is the pointer for the value which is stored inside the memory address of x, which is stored in xptr. So now when I'm going to run this program, let's say I just run this program, and now you can see over there what is written. Previous one is exactly the same, the two memory addresses over there, and value of x is 8, value of y is 9. Very simply. So what we have done just now, we have addressed the variable without addressing the main variable, but just its memory location. This is pointer. Now, what is the advantage of it? Now, the advantage will come more clear maybe in the next part of this series of video. But here at present, if you can closely see over there that you are addressing a variable without using the variable. So if supposingly you are going inside a function, we already know whenever a function is called, the variable is just passed, copy of that value is passed. It's passed by value. It's not passed by reference. So what happens if in the function you want to change a variable, just pass its pointer inside the function parameters and you can change it at its address. For example, let's say over here, what I do over there, I call it static x ptr and I call it equal to 10 and here I call it equal to 11. Now what will happen? When I run this program, what is happening? Static xptr will change the value of the memory address which this xptr is pointing out. So now when this command, the last printf will run, this will be printing 10 and 11. So let's say before this command, I want to just run this command also before this command. So let's see what happens. I am running this printf before this two are set and then afterwards. Let's see it changes or not. I'm not addressing x and y. I'm addressing two totally different variables over there. This is xptr, this is yptr, and I guess this is again some, I guess, error over there. Not an error, actually, that's the so now you can see what is happening. Value of x and y is 8 and 9. Perfectly true, because 8 and 9 were the values which we initialized. But afterwards, this is changed. You can do it over there. So here you can address a variable without addressing its own because you know its memory address. It's just like it. Supposingly, you don't know where I live, but somehow you find it out. Okay, where Saraslan lives, you come it and you hack into my computer physically or something and you bombard it. But since I have not told you my address, you cannot come to my place. So here, if you know the variable address or the memory address of that variable, you can do anything. So you can do anything inside even a function. That's actually the advantage of this one. And its major advantages in arrays. We'll come back to it in the next part in detail, not in this part. But this is pointers which I have just told you and explained you over there. And remember, if you have another variable, let's say character C equal to A. And here, if I want to now have a character C pointer, remember, the data type has to remain the same. This character and then this thing. And let's say I have this thing and supposingly and this thing. So what is I'm doing it over there? I am printing over here the three variables over there, let's say, and like this over here, value of xptr, value of yptr, and all this thing. So when I print it, let's say I just do it over there. So now you can see these are the three X, Y, and CPTR memory addresses which are being pointed out. These are the value of X and Y and C, and these are being printed over there. Of course, remember, whenever you are printing a character, you have to use percentage %C. Remember, these format specifiers are very, very important. And today I have given you percentage %P, which is used for memory address printing for pointers. This is something very important. Remember, because XPTR is a pointer over there with the static. When static adds with that variable name, it actually points out to the value which that memory address is pointing. If you don't need to use the static, then it prints just the address over here, which is over here. So here you are printing your XPTR and YPTR over there. And similarly, let's say I want to have a printf statement over here and value of CPTR. You can even change your CPTR over there. Let's say I change it to CPTR to B. So now what will happen when I will run this command, let's say, sorry, this not going to be, it is going to be static over there and like this. And now can see change. And when I run this command now, let me just increase this terminal window. You can see the value of C is B. Previously it was A. So this is the advantage of pointers. And this is all coming on from this static. This is called as pointers in C. Now coming back to the slides over there, because this is more than enough for the coding part. So coming on to what are pointers? You already know regular variables. We have just given X and Y variables over there. That was a regular variable. A pointer variable contains a memory address, just like XPTR, YPTR, and all that. It points to another variable, as I told you, using the AND symbol, provides an indirect access to value. Direct access is what? You use already num, X, Y, whatever. So if you want to use a variable, you just only go through it. So you want Sarah Salan, supposedly, you can go on and see my YouTube video. But if you physically know my home address or my lab address, you can physically come to me and then get me. But for that, you need to know my address over there. So this is just like an indirect. So this is a direct way, there is an indirect way. So this is an indirect access, which is called as pointers. And that actually gives you the memory address or something like that. Why we use pointers? As I told you, they modify variables in calling function, because you already know in functions, you don't change the variable. You only just change you send the copy of that variable and then it returns and it is back to the previous value. Unless and until it's a global variable, that's a totally different case, but that is passed by reference. Then a dynamic memory, it creates a data structures that grow and shrink. So now you know what this actually means. You know your variable address. So now you can add it, increases, decreases the value over there. And if supposedly all the variables are in succession, which means supposedly, what I mean by this, supposedly here in this is not the case. The variable addresses are not in succession. This is AC, this is A8, and then this is A7. So you can see A7 and A8, they both are the same, but AC is a little different. But if all the variables are in sequence, if they are all in sequence, then you can add or change your all variables. And this is something very easy, because then you're talking about an array. Here, these are three different variables of three different data types. And remember one thing, Y character over here is starting at A7 and the YPTR is at A8. The reason is very, very simple, because character is always stored inside 8 bits, which is 1 byte. Integer is stored inside 4 bytes over there. Remember, integer is stored in 4 bytes. That's why after A7, YPTR, now you can argue over there that this was Y above, C was below, so that why A7 is above here. This is all done by the compiler. The compiler decides for memory arrangement, because compiler is a compiler for your Windows, or here in case it's a Mac OS operating system over there. So it's actually deciding that which variable is going to be stored where inside the RAM. So don't worry on the sequence of the memory addresses, but these are hexadecimal numbers. So A7 is stored first, then after 1 byte, this is A8, and then after 4 bytes, then this is AC. And that is exactly the same way over there. So your memory is over here going to shrink or decrease. And this is much easier for shrinking or increase over there when you are having arrays, because arrays are in sequence. So if you have an integer data type, supposedly you have an array over there. Let's say I'm not going to use that array at present, because that's going to be the second part of the series of the lecture over there. But whenever you have arrays over there, arrays are can easily increase or decrease. You can even have your array increase or decrease by using pointers as well. We'll come back to this later on. So efficiency, you can pass large data without copying. So if supposedly in a function you want to pass on like 100 variables over there, you just, on all the variables are in sequence, you just tell the address of one variable, the starting of the variable address with a pointer, and the next 100 variables, the function will automatically take care of itself. Pointers are essential for array manipulation. We'll talk about this in detail. I just told you, because arrays are numbered according to your index number. So they all are in series. Function pointers, as I told you, you can pass functions as arguments. Now, this is something very, very important. At present, I can't give you an example at present, because this is a very, very important. That's why I have bifurcated this one into three parts over there. And pointers are one of the most powerful features, but they require very careful handling. This is something very, very important, because you are handling the memory addresses of your RAM. Then thing, as I told you, this is a direct addressing. The other one is indirect reference. So if you have a variable count that is having a value 7, of course, that 7 value is stored inside it, but that 7 has an address. If you store that address inside a variable which is count PTR, that will point to that memory address count, and that will actually be 7 over there. So this is called as indirect reference via pointer, which is actually by the static word we have just used it. So it's referencing a value through a pointer, and this is called as indirection. This is called as indirection or indirect reference over there. So this is the same thing which we have just done over there. So we are referencing our variables over there, xptr, yptr, by using this static over there. So we are accessing them over here and changing their values over there and accessing them. This is called as indirect reference over there. Then next thing, declaring pointer, as I've told you already, we have already done, we started with the example over there. So whatever variable you are pointing out, whatever variable you are pointing out to it, you have to use that data type over there. So if this count PTR is going to address integer area or integer data type address over there, then of course this has to be integer. If you are here price PTR, so this capital PTR is just a nomenclature normally used by C programmers worldwide. So you can use it anything. You can have a price underscore pointer over there. You can use price underscore P over there. The next slides is going to tell you on that. You can end with the PTR. You can start with the P over there. You can start with P underscore as well. It's totally up to you. You can use any other naming convention, whatever you want. You can use this PTR. You can use with start with P or with P underscore. It's totally up to you. Here, what I have used over there is capital PTR. So you can have this one very importantly. So here, this int static count PTR, this is read as a count PTR is a pointer to integer. That's all. Because at present, we have not given equal to, we have not initialized it with that and symbol of that variable, whatever it is. So it is just called as a count PTR is a pointer to integer. What integer, which address, still not known, because is equal to term is not written over there. But remember, Pointers can be of any data type. It can be character, it can be float, it can be double, it can be int over there, totally up to you. And the naming convention, as I told you, so they have to be either PTR, as I told you, or you can use P in the very start, or you can start with P underscore, but it has to be something like this one. So actually the programmer, if anyone else releases your program, so you can actually see that this is actually a pointer. Already, whenever you are going to declare a pointer, you are going to use this static word, but still you should be having the name of that pointer, having that word PTR, capital PTR, or simple just small PTR, or P underscore there. So that will actually make me easy for anyone else who is going to read your program. Common mistake which is done in this multiple declaration is this, that if in this command you have written int static count PTR, and with this comma you write countdown, count over there, another variable. Now remember this is going to be a pointer, but this one is not. Here count PTR is a pointer to int, but count is just an int over there. Remember, this is a, so just to avoid this mistake over there, always write down in two different lines over there. So this is something very, very important which you have to do. Okay, so coming back to this thing, whenever you are going to initialize, now I have used in our code over there initializing. Initializing is being done by this and symbol, but if you don't, supposedly you want to tell initially that what is that and symbol or whatever over there, then you can initialize it equal to 0, or you can initialize it to word null. Now, null is a library which you have to define as stdf.h. This is something very important. So if you want to write down the word null over there, let's say if I want to write down the word null over there, so I will have to include Sharek over there, and here stdf dot h. And here now, supposedly, let's say I have an int b equal to 10 over there, let's say, and here I want to write down int static bptr, and here I write down the word null. So now null is, you can see automatically null has been, now it automatically giving me, I don't want to have it. So null is a reserve word, just like you reserve word defined by using the word define over there, you are using those constants over there. So whenever you add this library, null is automatically added. So null actually means zero, nothing over there. So null is actually equivalent to zero over there. So that is a part of STDF, standard definition. The definitions inside it, we'll talk about it in chapter number 8 or 9 in detail, but at present just go with this, that this is stdf.h. A pointer with value null points to nothing, which means it's still not defined with any variable address. It points to nothing over there. So always initialize pointers to prevent errors over there. This is something very important. And if you want to have an address of a variable, you already know int num is equal to 5, int static ptr is equal to and is already, I told you the address of it. So and num is going to be, so the memory address of that num is going to be pointed out inside this PTR word over there, and static PTR is going to give you the value which is stored inside that memory address at that RAM location. So very simple. Another one question over there before we point out the other thing, the definition int count static PTR count, if this specifies that count PTR and count is wrong, this is totally wrong. I told you that this is a pointer, this is a pointer, count PTR is a pointer to int over there, and int count is just simply an integer over there, it's not a pointer over there. So the answer is false. Actually count is an int, not a pointer to an int over there. The static applies only to this count PTR. So whenever you have a word, if you want to have a static here as well, then it will be a pointer. Otherwise there is no static, then this is not a pointer over there. Remember, this is something very, very important. Then two essential point operator. This is already talked about in detail. Address operator, scanf, you remember it. And whenever you want to find out the memory address of its it's a unary operator over there. So and the variable. So here, just like in your code, what we were doing over there, you had x and y. So here I had and x and y and c over there. So you are actually trying to find out. Now here, when you have made it null over there, let's say if I made it null over there, and here supposedly I call it printf, and here like this. So what I've done, value of bptr is equal to this thing. Now what it will be giving me, if I now just run it, let's say what it will be giving me, let me just run it. So where is that? This is 0 into 0. Why? Because this is null. This is null. This is 0. It's not pointing out to any memory inside your RAM. It's null. But here, if in place of this one, after this command, let's say I give it an x, sorry, b ptr equal to this and b, and then if I again run it, now this will be changed to, you can see, another address. So null is something 0, and the other one and is going to give you the next symbol over there. Then the indirect operator, I told you, this is the indirection operator or the indirect reference over there. So it's also called as a dereferencing operator over there. So it returns the value at the address to which the pointer points. Remember, this is a very technical word over there. Static combined with the pointer variable, it can be bptr, xptr, yptr, so returns the value at the address to which the pointer points. So xptr here, xptr is pointing out to this address, but when in the next line you write down static xptr, this gives us the value of that, and that is x over there being printed, you can see over there. So you are printing your x over there, sorry, the value which is pointing out by that address which is stored inside it over there. So this is called as the indirection operator, or also called as a dereferencing operator. I guess dereferencing is a different word over there. Indirection, as I told you, because this is indirect way of accessing a variable, so that's why it's called as the indirection operator over there. The address operator, I have already told you, nothing fancy. It's again just elaboration of the same thing over there. So you have a variable y, and that variable y is having a value 5 over there, but you make another yptr, what it has the address of y. So when you combine static yptr inside some printf statement, or inside some logical or some arithmetic calculation over there, and remember, you can use even this one. Let's say I want to just give you one example over there. Let's say what I have x and y over there. Let's say I write down a command over there, and in this one, instead of writing xptr and something like this, let's say I put it static yptr equal to static xptr plus static yptr. Sorry, yptr over here. So what I have done over there, I just written a mathematical expression, value from xptr, yptr, y will be having. So what will happen now, because of this code, because this is pointing out to, oh, sorry, this is static over there, not and over there. So these all three are pointers. So the value of yptr, which is actually 9, will now be become equal to 8 plus 9, which will be 17. So now just run it and just see it, what will happen. So when I run it over there, I guess I have not done some mistake. Again, this AI actually comes in between. You can see the value of y is 20. So you are addressing the same variable because if you know its address, very simply. And that's why it is called as the AND operator or the address operator, because you can get easily the variable address very easily over there. Then memory representation, just very simple. Again, a slide over there which is going to tell you if int y is equal to 5, int is static yptr is equal to and y. So the address of y will be inside yptr. So yptr will be having this address, and this of course is a hexadecimal number. I'm not going to talk about in detail on this thing. So y is at a location 60,000 hexadecimal number, and it has a value 5 stored inside the RAM. Remember, this is the address of that RAM slot where this value is stored. But this 6000 will be stored inside yptr, which is inside another location. Of course, that's another variable. It will be stored inside another location, and that will be having 6000. But when you will combine static yptr, so this will automatically tell the compiler that go at this address and fetch the value which is inside that memory address inside your RAM over there. So just very same thing, printf percentage d static yptr. This will print 5 because y is being pointed out by this AND operator. The address is being copied inside yptr, the same thing which you've just done in the file over there. So using static in this manner is called as a dereferencing a pointer. So you are dereferencing a pointer. It follows the pointer to get the actual value at that address, whatever is stored inside that pointer variable. So dereferencing an uninitialized pointer. Now this, remember, if this statement was not written and you just write down this thing and this and is not there, you have not initialized it, so this will cause a fatal runtime error. The compiler will not be able to find out, okay, this is not initialized, it's so it may crash. So different results can be on different systems over there. So it can corrupt the important data also, and it can create security vulnerability because you are not giving the address, and maybe it has some garbage value. So maybe it goes on to some other memory address, or maybe you are running some browser at that time, and that will be actually be giving you the value over there. So that's a big problem over there if you are going to have something like that. So you have to avoid uninitialized pointers over there. Then next thing, an example, and I guess I don't need to go through this example, but still again, I will just go through this example. This is a very simple example over here. Let me just go through this one. And in this example, same thing, I guess nothing fancy. I've already done this one just now in front of you, this example. You have an int variable x7, and then you have a pointer, and that is pointing out to the address variable or the memory address of the a. So the address of a is this, and you can see this is and a and aptr. So you are writing down the address of a as and a, which is one way. The other one is because aptr is pointing out to this one already, you have initialized it. So these both will be giving you the same answer over there. If you go on the next line, line number 11, the value of a is, here you're just printing out a, and then you have static aptr. So this will be printing you the value of a, and this will also be giving you the value of a, because this is pointing out to the memory address of variable a stored inside aptr, and this is indirect referencing over there. So this is static is giving you that. And then very, very important, these two lines are something very important, and this is showing you that static and symbol or ampersand, normally it's also called that, and normally in our culture you call it as the and symbol, but it's also called the ampersand. They are complements of each other. So they are complements of each other. So you here you are printf, and here these both you have and static aptr static and, so they both are canceling each other. So let's see what this happens. So if I just run this program now, let me just run this program, and when this runs, now you can see what is happening. Address of a, this first line is being printed over there, they both are exactly the same. Why? Because this is and a, automatically is giving the address of a, and this is the pointer of a, which has been already initialized as and a. So they both are giving the same value. Next thing, value of a is 7, and value of pointer of a is also 7, because it's giving the same address over there, or same value at that address over there. Then showing that static and they are complements of each other. So you can see over there they are canceling each other. So it's just printing out aptr, and this is static and they both are canceling each other. It's just like you have two negative signs with each other, they cancel out. So same thing over there, you have and static, they both are canceling each other effect. So what is just printed is exactly the same thing which was printed here. So you are having the aptr value being printed here, here. This is actually giving you the indirect reference of that aptr, or dereferencing the variable over there. So it's exactly the same thing. This is exactly the same thing, demonstrating the and the static operator in this example. I just did it in front of you, and the explanation of the same code over here. And here, just same thing, the address of a is the value of aptr. Value of a is equal to the value of a static aptr. As I just told you, this is actually dereferencing works over there. And then the and static, and then static and, either you use any of them first or later on, gives the same result, because the operators are complements over there. Then another question over there for you importantly, what it does, I have a double d equal to 98.6. It's a variable, again, double integer type, also double data type over there. Then I have double static dptr. Now I have not initialized it. The following statement assigns variable d address to pointer dptr. So does this works over there? Now, question to you. The variable dptr is then set to point to d. Does it works over there? Yes, it will work. Why? Because this is going to give you the correct d pointer, because you don't have to use static over there. dptr is the variable name actually, which is a pointer. But when you use static, then you get the value from there. This dereferencing the pointer, remember. So here dptr equal to and d is actually telling you the address of d going to be stored inside it. But when you are going to add static dptr, this is going to take the value from that one, and it's going to give you the value which is at that memory address, which is it pointing to. Next thing, as I told you, the pointers are used for two things. One is by pass by reference. This is by using pointers. Pass by value, which is by default for non-arrays. Up till now, whenever you are going to give an argument inside the function, you always give by pass by value. So the copy of the value is passed. Function cannot modify the original variable, and it is used for simple data types over there. Here, when you are using pointers, now instead of having given the variable, now you're going to give pointers over there. When you are going to give pointers, the address of the variable is passed. So you're now going to put static PTR or whatever that variable PTR is, and then function can modify the original variable without accessing the original variable. You are just giving the pointer of that variable over there. So this is the more efficient way for large data. I told you that if you have 100 variables, you can't pass it on, and all of them are in sequences over there, then you just need to tell the first variable, and automatically the function can handle by increasing that value inside that variable pointer over there. So if xptr has a value supposedly 0 into 1000, if it's an integer, so the vex value supposedly is y, it is at something at 1004, so automatically it will be accessing that. Then 1008, maybe next variable 1000, and then of course 4 after that, it will be c over there because it's hexadecimal over there, so it can be accessed over there. So it can return multiple values. Remember, functions can only return one type over there, so it can now return multiple values because you are changing different memory address values over there. So this is something very important. Pass by value, another example over there. We have already done this example previously over there. It's a function over there. You can see this is the prototype of the function on the very start over there. This is int cube by value. This is int n over there. Simple. There is no pointer inside this function. You can see there is no pointer over there. I have an int number over there. Printf original value number. So I am printing the value. So it will be printing 5 over there. Then I call the function cube by value and I pass this value number, and I save this number inside this one and call it. So now I'm changing this value of number over there. So now when I'm going to printf again, this will be changed too, because inside the function, what I'm returning, I am multiplying the number itself by itself and itself. 3 times I'm multiplying it. So you are taking the cube. So the function name is also cube by value. So it will be 5 and 125 over there. So it's a very simple of pass by value. You are passing the value of the variable. Remember, you are not passing the variable over there. You are passed by value over there. Here, because since I have written number is equal to this thing, that's why it is changing the main variable. If supposedly this statement was not there and I was just calling the variable over there or this function over there and I had only number, then this will be 5 also here, 5 also here. Okay. Now, pass by reference. What does that mean? Pass by reference means that instead of n, I am pointing out to nptr. This is static nptr. I am pointing out to the memory address of that nptr over there. So now, instead of now having this, I'm just calling the function, and what I am passing inside the parameter, I am passing and number. So what it will give? It will not give the variable. It will give the address of that variable, which is that variable number. So this and number will automatically take inside nptr. So when I'm going to call nptr and multiply it, now here, this is a tricky thing. This is the variable name, or you can use with the dereferencing pointer over there. This is another one. This is another one. And this one is that multiplication sign over there. So you are multiplying the value which is coming by the dereferencing of that pointer with again another value with another value. So what is happening? You have 5, 5, 5 being multiplied. And now when you are going to printf, just simple number, because you have changed inside that memory location. Remember, you have changed the memory location of that pointer. You have changed the memory location automatically over there. So now your answer will be 5 and 125 over there. So here, this is a very classic example of having a pass by value and pass by reference over there. And this pass by value and pass by reference, I guess I have already an example here in my over here. I guess this is that, not this one, actually, this one is, yes, this one. So you can see now exactly the same example. We just done it. This is the function over there and here. Now, if I don't call this number, let's say I don't call this number equal to, I just call the function cube by value and number. So what I'm doing, I'm following a function, passing this value of 5 inside it. It will go inside it and return whatever, but I'm not saving it inside something. I'm not saving it inside something. Let's say I call it int x is equal to something, let's say, and I run this function. So what you can see now, it has printed the original value of number is 5. The new value of number is also 5. No change. Why? Because I have int x. But if I put number over here, if I put a number over here, now I'm changing the value. I'm changing the value. So when I will run it, now this will be 125. But here I can do the exact same thing by using the pointer. So here I am having this pointer nptr, static nptr, multiplied by static nptr, multiplied by static. Remember, you have to use this static with the pointer variable. Otherwise, it's not going to check or it's not going to bring that value. So supposedly you have just nptr over there and you don't use this static over here, this will be problematic. So if I just run it, let's say, you can see its expression must be arithmetic type. So it's not arithmetic type. Why? Because the compiler is telling me, because you have to put this static over there, because these are pointers. This is going to just give me 0 into hexadecimal memory address. You can't multiply a hexadecimal number with a decimal. So it will be a problem. That's why the compiler is not going to give me. So I have to put this static every time whenever. So your expression should always have your statics over there. Totally up to you. If you want to multiply it by supposedly 10 over there, you can put any number over there. Let's say, and I just put it over there. Oh, sorry, I guess missed that R over there. So when I have this one, you can see now this is 1250, because 5 into 5 into 5 multiplied by 10 is equal to 1250 over there. So it's a very classic example. Kindly go through the example. This is an example available from the chapter and problems over there. So this is giving me a very example. So just a small table which is telling you what is meant by pass by value versus pass by reference. So pass by value, the copy of the value is transferred. The function parameter is a regular variable. You just pass on the variable value, and calling syntax is simple function X over there. Modify the original? No, it does not. Unless and until you are returning and then saving it. That's a totally different case. Multiple returns? No, you can't do that. And it's default for simple types. But when you are passing by reference, then you are passing the address pointer over there or using the pointers over there. Function parameter is a pointer variable. You're having, whenever you are declaring that function over here, just like you have declared the function, this is going to be pointer static variable number over there. So this is going to be very important over there. Then coming on to this one, you already know, whenever you want to call the function, you have to put the memory address. You can't put X over there. You have to put memory address, which is done by the AND symbol. Modify the original? Yes. Modify multiple returns? Yes, it can do, because now you have the memory address. You can modify other variables also. You can do that one very easily. Then it is default for arrays. I will come back to this one in the next video, because arrays is a totally different topic. And for arrays, you don't need to put this AND symbol. We will come back to it later on when we are talking about this one. So step by step, just to give you an example, what is happening. So before the call, number was equal to 5. After the call, n is still 5 in the function. Copy is created. But after cubing, the same function we are talking about, we just discussed just now and I showed you in the Visual Studio. So n becomes 125, but number is unchanged. But when you return it, 125 is returned to the main and you have number equal to 125. Why? Because here you are changing this over here and this value is being saved inside, whatever is returning is being saved inside the variable number. If you don't do that, then number is never going to change. Whatever you do inside that function is not going to be replicated outside in the main function over there. So this is pass by value. But when you do it by pass by reference, then you already know you are already going to change it at the memory location by using the pointer, which is called as 125 over there. So after return, the number is 125 inside the main, and this is without any return or something. You're just changing the reference over there of that pointer over there very easily, like this way. Very importantly, very importantly, this is, I guess, before I go on, I guess this is the last slide and I will just finish it off here. So very important point over there, whenever you are giving a function and you are writing down it's over there, you always have to write down, if it's taking a pointer as a parameter, always write down that data type, whichever data is going to come from that pointer. Static nptr, this is the normal over there. Function parameter must be a pointer. And when you are going to give a prototype, there are two ways of doing it. One is by just writing down this one and then this semicolon mark. We already remember how you are going to have the function prototype. Or don't write this nptr, just write down static. Automatically this knows that this is going to be a function having a parameter such as a pointer. But yes, when you are going to give the full definition of the function, then you have to write down the full NPTR, because that NPTR is going to be used somewhere inside. Just like this case over there, this one here, this is n static NPTR. But here, if I don't write this one, let's say I don't write this one and I just save it over there. So it will still work over there. You can see it's still working. Why? Because in this prototype, I am not telling its name. I'm just telling that it's a, sorry, I'm just going to write, not just, I'm just going to have this one and I just run it. You can see it's still running. So this static is telling me that the parameter is the pointer. It will be told afterward what is that number, and that what is that variable name, and that is NPTR. So this is also allowed, and this NPTR is also allowed. Totally up to you, whatever you want to use this thing or the other one, totally option, or parameter name is optional. Remember this thing. Arrays are different, and whenever you are going to call an array or you are going to send an array as a parameter, remember you are not going to use the and symbol over there. I will talk this one in the next video over there. I hope you have learned something in this one. Kindly try to do some examples using functions and all this one. And in the next part, we are going to discuss about how arrays are discussed inside your pointers, and how arrays are, because arrays are sequential data objects. Because whenever you define an array from 0 to like supposedly 9, and it's a 10 object array or a 10 index array, then of course you can easily access it because they are in successive nature over there. So I hope you have learned something and this was something good for you. See you again.